Now in this lecture, we're going to solve problems on the Fourier transform using properties. So we need to find the given signals Fourier transform to use the properties. So now the first one is x of t is equal to sine omega naught t. Now if you use this the equation of this Fourier transform, so it is a somewhat lengthy procedure to find the Fourier transform of this signal. But if I use the Fourier properties of the Fourier transform, it's very easy. That is, first we need to expand this signal using Euler's relation, that is e power j omega naught t minus e power minus j omega naught t by 2j, and this is x of t. Now what is the property we need to use is, that is e power 2j into e power j omega naught t minus 1 by 2j e power minus j omega naught t. This is x of t. What is the property we need to use? That is frequency shifting. So frequency shifting property. So what is the frequency shifting property? If there is any e power j some m t, or generally we can say j omega naught t, right? If there is a j omega naught t, so what is the Fourier transform is some x of t. Actually x of t should be there. Then simply x of j omega minus m. So whatever the constant here, so it will come here. So if it is a plus, we will get minus. If it is something like this, e power minus j omega naught t into x of t. So what is the Fourier transform for this one is e power j omega, here minus, so we will get plus here. So omega plus omega naught. So shifting in the omega domain. Here m means we will get m, that is a constant. Here j omega naught, that is again constant, so we will get constant here, but plus. Now first we need to find what is x of t here. So x of t is nothing but a constant 1, right? So we have seen for 1, what is the Fourier transform of 1? So I told you in the previous lecture, the a means a. What is the Fourier transform? It is 2 pi a into del omega. So 1 means what is the Fourier transform? Simply 2 pi del omega, right? Now what we need to do, e power j omega naught t by 2j. So anyway, this is a constant, so it will become 1 by 2j into 2 pi del, see, this is the frequency shifting term, so omega minus omega naught. Similarly, for e power minus j omega naught t by 2j. So what is the Fourier transform? See, 1 means 2 pi del omega. Now if I multiplied with here e power minus j omega naught t, so this will become 1 by 2j into 2 pi del of omega plus omega naught. Here minus will get plus. So if I add these two, so what I will get, x of t, which is sine omega naught t. What is the Fourier transform? So 2 will be cancelled. 2 will be cancelled. Pi by j is common. Pi by j, and del of omega minus omega naught minus del of omega plus omega naught, right? So this is the Fourier transform of sine omega naught t. So using the frequency shifting property, right? Similarly, we'll find the cos omega naught t. So I'm directly finding. So it will be written as j power j omega naught t plus e power minus j omega naught t by 2. There is no j here. Now it will become what? So 1 by 2, the Fourier transform I'm writing. So 1 means 2 pi del omega. So and omega, so e power j omega naught t, frequency shifting. So it will become 2 pi del omega minus omega naught plus 1 by 2 pi del, so this is a minus, will get plus omega naught. So here plus only, because e power j theta plus e power minus j theta by 2. Again 2 cancel. So what is the Fourier transform of cos omega naught t? So it says pi into del of omega minus omega naught plus del of omega plus omega naught. So this is the Fourier transform of cos omega naught t using shifting frequency shifting property, right? So we will see the two problems on the time shifting property, right? Now, if you see, this is e power minus 2 into t minus 1 u of t minus 1. So, shifted by t minus 1. So, what is first we will have to find is, suppose this is x1 of t, I have to find first what is x of t. So, without shifting, that is e power minus 2t into u of t, right? Now, what is the Fourier transform of e power minus 2t into u of t? We know that for e power minus at u of t, what is the Fourier transform? Simply 1 by a plus j omega, right? We have seen this is a basic signal, so we should remember this one, right? Now, in place of a, we are getting 2, so e power minus 2t u of t. So, what is the Fourier transform? 1 by 2 plus j omega. Now, we need to shift. That is, we know by time shifting property. What is the property? It is tells if x of t is having a Fourier transform of x of j omega and x of t minus t naught. What is the Fourier transform? Simply e power minus j omega t naught into x of j omega. If it is a plus, we will get plus. If it is a minus, we will get minus. So, plus or minus means we will get plus or minus. Now, we need to use that property here. Now, see, e power minus 2t ut we got. Now, it is shifted by t minus 1, right? A minus. So, what we will get directly e power minus 2 of t minus 1 into u of t minus 1. Now, what is the Fourier transform? Simply e power minus j omega. What is the t naught? 1 only. So, e power minus j omega into 1 by 2 plus j omega. That's it. As simple as that. Right? Now, so one more question. We will do this one. So, x of t is equal to e power minus 2 into mod of t minus 1. So, from this, first we need to do this e power minus 2 mod t. Now, we know e power minus a mod t. What is the Fourier transform? It is 2a by a square plus omega square. Now, in place of a, we are getting e power 2. That is e power minus 2 mod t. What is the Fourier transform? 2 into a. So, 2 into a means 4 by 2 square. That is 4 plus omega square. Now, we need to do the shifting. That is t minus 1. So, what is the Fourier transform? E power minus 2 into t minus 1. So, Fourier transform is, so only shifted, that is by 1. So, it will become e power minus j omega because it is a minus here into 4 by 4 plus omega square. Now, you may get a doubt that, so what happens, suppose this question I am doing this one. Suppose e power minus 2t u of t minus 1. Something is like this. Then, what is the Fourier transform? Even there is a shifted version here, right? Minus 1. So, what we do is, we will make this one as something like this. E power minus 2 into t minus 1. So, what extra we added? Minus 2 into minus 1. So, minus 4 plus 4 we added. Plus 2, sorry. So, it will be added here again, minus 2. Then, if you expand this one, minus 2t plus 2. So, e power minus 2 into e power 2, it will be cancelled. Then, u of t minus 1. Now, see, it is as simple as the shifted version, and there is a amplitude is multiplied. So, what is the Fourier transform? E power minus 2 into, for shifting, it is e power minus j omega by e power minus 2t ut. That is 2 plus j omega. So, whenever there is something, here shifted version, here not shifted version, then we have to make same, right? But if here t minus 1 and here u of t, that is not a shifted version. So, don't make here t minus 1 plus 1 etc. Only here there is a shifting. Then we have to make here also same like this. Then we have to multiply here, not in the time domain. Okay. So, this is how to do the using time shifting property. Now, two more questions. One is, again, it is time shifting. So, one more is using differentiation and shifting version also. Now, here x of t is given delta t plus 1, delta t minus 1. We know what is the Fourier transform of delta t? Is nothing but simply 1, right? We have seen in the previous lectures. Now, simple, it is delta t plus 1, the time shifted by advanced version. So, plus means we will get plus, that is e power j omega into 1. So, Similarly, delta t minus 1. So for it is a Fourier transform e power minus j omega into 1. So plus means, so delta t plus 1 plus delta t minus 1. So what is this? We'll get e power j omega plus e power minus j omega. So this can be converted into cos also. So it should be 2 into 2. So 2 cos omega. What is the time domain signal? It is delta t plus 1 plus delta t minus 1. So simple, very simple. Now we'll solve this one. That is question number 6. X of t is equal to d by dt of x of u of minus t minus 2 plus u of t minus 2. To solve this one, what we need to do is, first we will draw this signal, then we will differentiate that signal, then we can find, right? So what is the u of t signal? It's nothing but t greater than 0 will get the impulse, the step response as the amplitude is 1 after t greater than 0. Now what is u of t minus 2? It is a delayed version, that is by 2 here. Amplitude is 1 only. Again we need to find u of minus t minus 2. That means just reversal of this one. So what we will get? Simply like this, minus 2. Now if I add these two, what is the waveform we will get? Something like this, minus 2 to 2 0, then less than this and greater than this will get amplitude as 1. So this is the some x1 of t, this is t. But what we need, differentiation of this signal. Now if I differentiate this one, so to find differentiation, first give the arrow marks, right, the directions. Now whenever there is a constant, the differentiation will be 0, but whenever there is a discontinuity, you will get impulse. Similarly here 0, so here impulse is there, so you will get one impulse here, then it is 0. So what is the impulse? Area will be 1. So d by dt of x1 of t. So what is this? At minus 2 we will get one impulse, that is area will be minus 1. Similarly at 2 we will get one more impulse and area is 1. So how can I write this signal? So this x of t, the differentiation is over. So simply I can write minus, see, amplitude is 1 or area is 1, minus delta t plus 2 for this signal, because it is advanced version, plus delta t minus 2, because area is 1. See here, why I am not writing 2 into, so this is the time version and this is amplitude or area. So area is 1 only, that's why it is 1 into delta t minus 2. Now Fourier transform of this signal to find is very easy. What is the delta t Fourier transform? It is simply 1. Now what is delta t minus 2 Fourier transform? It is time shifted, so e power minus j omega 2 into 1. Similarly, what is the delta t plus 2 Fourier transform? It is e power j omega 2 into 1. And here minus is there, so minus means minus. So if I add these two, what I will get? Delta t minus 2 minus delta t plus 2. The Fourier transform is e power minus j omega 2 minus e power j omega 2. So this is the answer. We can simplify this one. See, it is looking like e power j theta minus e power minus j theta. So if I take minus common, it will become e power j omega 2 minus e power minus j omega 2. So 2j is missing, so I will make is 2j here and 2j in the numerator. So it is sine 2 omega into 2j. So what is the final answer is minus 2, see here, 2j into sine 2 omega is the answer, right? So this is the x of t. What is the Fourier transform? One more question, that is x of j omega is equal to, now it is x of j omega is given. Now we need to find the inverse Fourier transform. So x of j omega is given as 2 pi del omega plus pi into del omega minus 4 pi plus pi into del of omega plus 4 pi. Now we know that what is the Fourier transform of 2 pi del omega? That is inverse Fourier transform. It's nothing but 1 only, right? Now what happens when there is a shifted in the frequency domain? So it will be multiplied with e power j omega naught t in the time domain, right? So what we have to do is, so pi 2 pi del omega is okay, fine. Next, pi into del of omega minus 4 pi, right? So what is the inverse Fourier transform, right? So there should be 2 pi, right? So what we do, 2 pi by 2. So that means 1 by 2 into 1 for this shifting. So it will become e power j 4 pi t. Here minus, we should get plus here because it's a frequency shifting. Similarly, next one, e, that is 2 pi by 2 del of omega plus 4 pi, right? The inverse Fourier transform. See, directly I'm putting this 2 into 2 here. So it will be 1 by 2 into 1 into e power minus j 4 pi t. See, because it's a plus, we should get minus. So if we add all these things, so we'll get the overall Fourier transform, inverse transform. That is 1 plus 1 by 2 into e power j 4 pi t plus 1 by 2 e power minus j 4 pi t. Now what is this? By simplify, this is 1 plus, this is e power j theta plus e power minus j theta by 2. Simply cos 4 pi t. Right? So this is how to do using this frequency shifting when the x of j omega is given. Now we need to find the x of t values. Right? So this is the x of t. Next we solve this one. X of t is given, that is x of j omega. Now we need to express Fourier transform of these given signals in terms of x of j omega. Again, we need to use the shifting, scaling, everything is we need to use. So one by one we will do. So this is x of 1 minus t, x of 1 minus t. I can write like this, x of minus t plus 1. Whenever we are applying the Fourier transform, first take minus comma. So t minus 1, right? So it will become minus t plus 1. So what we need to do here is, first, what is x of t Fourier transform? X of j omega, right? Now x of t minus c, we can use simply first the reversal, x of minus t. So Fourier transform is x of minus j omega. Now we need to shift, that is minus of t minus 1, right? Then simply e power minus j omega into x of minus j omega. So we need to do whenever there is a reversal and shifting. First make a minus common, first to do the reversal, then do the shifting. Similarly this one. So I'm writing like this directly, x of minus of, it will become t plus 1. Now first one, what we need to do, first we will to do minus t. So Fourier transform will be x of minus j omega. Now we will do the shifted, minus of t plus 1. So what is the Fourier transform? E power j omega I will get, x of minus j omega. Now if I add these two, what I will get? The final answer is x of minus t plus 1 plus x of minus t minus 1. What is the Fourier transform is? See, x of j minus j omega, x of minus j omega is common. So x of minus j omega, if I take common, it will become e power j omega plus e power minus j omega. So what is this? J theta plus e power minus j theta by 2. 2 is not there, simply 2 cos omega into x of minus omega. So remember, whenever we are doing this scaling and reversal, first we need to do this minus outside, then only we'll get same answers, right? Next one, the second signal, x of 2t is x of 3t minus 6. Again, we need to take x of 3 common, so it will become t minus 2. So what we need to do first, same procedure, that is first we will do x of t, Fourier transform, x of j omega. Next, first scaling, 3t, the Fourier transform is, so scaling means 1 by mod a, x of at means 1 by mod a, that is 1 by mod 3, x of j omega by 3. X of at means 1 by mod a into x of j omega by a. Next we will do the shifting, 3 of t minus 2. What is the Fourier transform? E power minus j omega 2, right? Because scaling is 2, I mean shifting is 2, by mod 3, or simply 3 also we can write, e power j omega by 3. So this is this one. Now the third one, it is x of 3 of t is equal to d squared by dt squared into x of t minus 1. So differentiation property, first what is x of t? Fourier transform is x of j omega. Then we will do the shifting version, x of t minus 1. The Fourier transform is e power minus j omega into x of j omega. So there is a two type second derivative. So first d by dt of x of t minus 1. What is the Fourier transform? Simply multiplied with j omega. E power minus j omega into x of j omega. So one more time, if I do the differentiation again, dt square x of t minus 1 Fourier transform, again it will be added with j omega. So j omega square e power minus j omega into x of j omega. So j square means minus, so minus omega square e power minus j omega into x of j omega. So this is the final answer, right? So two times I can directly multiply d square by dt square, but first we will do the step by step, then when you get in the gate exam or something, so directly substitute j omega whole square, right? Next we will see this one. So e power minus mod t is directly given 2 by 1 plus omega square. Now we need to find the Fourier transform of this signal and this signal. Now, so t in time domain, so we have to add differentiation in the frequency domain. So that is the differentiation in frequency is the property now. So what is this? T into x of t means we know the property is j into d by d omega of x of j omega, right? First one is that one. Second one is the duality concept, right? So duality principle, this one. Now first one will solve like this. So e for minus mod t, so Fourier transform directly given 2 into a. 2 into a is 1 here, so 2 by a square, that is 1 square plus omega square. Now what we need to do, t into e power minus mod t. The Fourier transform is j into d by d omega of 2 by 1 plus omega square. So if I solve, what we'll get? So d by dx of 1 by x. So minus 1 by, see this is 2 is common, so 2 common 2j. So 1 by x means minus 1 by x square plus omega square into, so I assume this is x, so we need to differentiate this one also. So 2 omega we will get, right? So the final answer is minus 4j omega by 1 plus omega square whole square, like this, right? Now using this result, and we need to find this one, 4t by 1 plus t square whole square, right? Now solve the option B. Now we didn't find the Fourier transform 4t by 1 plus t square whole square. Now we seen if there is a t into e power minus mod t, what is the Fourier transform? We got minus 4j omega by 1 plus omega square whole square, right? Now according to the duality principle, if I take this one in place of omega, if I replace with the t, so it will become minus 4j t by 1 plus t square whole square. So for this, what is the Fourier transform we will get? So we need to use this one, that is 2 pi into x of minus omega. So what is the 2 pi into x of minus omega? In place of t, we need to substitute minus omega. So it will become minus omega into e power minus mod minus omega. So what is this? Minus of mod means we get minus 2 pi omega e power minus mod omega only, right? Now this is the Fourier transform of minus 4j by 1 plus t square whole square. But we need only 4t by 1 plus t square. So if I multiply with minus j here, or simply j, yeah, we need to substitute. See, I don't read minus j here, right? So 4t by 1 plus t square whole square. So this minus j, if I minus 2 pi by minus j into omega e power minus mod omega. So it will be minus minus cancel. So it will become minus 2 pi j. If j is going up, it will become minus 2 pi j into omega e power minus mod omega, right? Next we will see this problem. So y of t is given x of t convolved with h of t, and g of t is given x of 3t convolved with h of 3t. So we need to find the relation between g of t and y of t, and we need to find what is a and b. Now here we need to use the convolution property. So what is this convolution property? Is in time domain, if there is a convolution, in omega domain or frequency domain, it will be multiplication. X of j omega into h of j omega. So we use this property, then we can find. So from the first equation, what is y of j omega? Is nothing but x of j omega into h of j omega. Equation 1. Now from the second equation, that is x of 3t convolved with h of 3t. First we will find what is the Fourier transform x of 3t. That is, we know that by scaling, so it will become 1 by mod 3 x of j omega by 3. Similarly, h of 3t. What is the Fourier transform? What we will get? 1 by mod 3 h of j omega by 3. So I can have simply 1 by 3, 1 by 3. Now from the second equation, what is g of j omega now? So g of omega or j omega is equal to x of j omega, which is 3t. So 1 by 3 x of j omega by 3 into 1 by 3 h of j omega by 3, right? So what is this? It will become 1 by 9 x of j omega by 3 into h of j omega by 3. This is equation 2. Now we need a relation between this g of j omega and y of omega. Now if you see here, so if I substitute x of here omega by 3, then we should get omega by 3 here, right? Then to make this 1 by 9, so from 1 and 2, so from 1, suppose from equation 1, if I make y of j omega by 3, so what we will get? X of j omega by 3 into h of j omega by 3. So see here, this is same as this one, g of j omega. So I can write g of j omega is equal to 1 by 9 into y of j omega by 3, right? See, x of j omega by 3, h of j omega by 3. So what I substitute from equation 1, it is same, right? So that's why g of j omega is equal to 1 by 9 y of j omega by 3. Now if I see the scaling, it should be 1 by 3 into 1 by mod 3 into y of j omega by 3. So that is g of j omega. Now if I take inverse Fourier transform, g of t will become 1 by 3 into, for this relation, so it will be y of 3t, right? So then what is a here? A is 1 by 3, and what is b? It is simply 3, right? So we need to use this convolution property as well as the scaling property. Then we will get answer as like this, right? So just mathematical manipulation only, right? And this convolution property and scaling property. So final answer is this: a is 1 by 3, b is 3, and j of t is equal to 1 by 3 into y of 3, right? Now I solved some the textbook problems from the Oppenheim, right? You do by these concepts, so maybe gate problems or just textbook problems only, right?